What I'm about to show you is on an NC23 API rotary shoulder connection. On the right here, this is a left-handed thread. And you can tell a left-handed thread because the thread groove or the helix are going up and to the left, and your pull-out thread is stopping, coming out in the counterclockwise rotation. Whereas on a right-handed thread, the helix angle is angled to the right, and when the last thread pulls out in a clockwise direction onto the cylinder diameter. Next, we're going to go to the two methods of setting: our mic track and also the rod setting standards. What you see in front is a 12-inch mic track. It has a linear glass scale, a movable cage, and on the left there's a set of flat mounting blocks that simulate gauge blocks. I'm going to zoom in on sitting on top of the carriage is a rod setting standard that has a stainless steel tag on it, and that tag shows what connection it's made for and what the length of the rod is. Next, we'll go into setting the gauge. What's being shown is the PD 8001 RSC with electronic indicator for measuring the pitch diameter of rotary tool joint from the NC10 all the way up through 6 5/8 regular. There are about 4 or 5 sizes that are larger than the 6-inch capacity of the frame itself. This is my NC23 rod standard, which I showed you previously on the mic track. We set the gauge to 0, press the center blue button when you get to your lowest reading, and you have just set the gauge to measure the pitch diameter of the connection that the standard was designed for. Now, using the proper length profile template, every profile template has the threads per inch, taper foot, and the thread form. I set it down into the thread, and I run it around until she basically touches the shoulder. I back up, I hold the thread form firmly, the profile firmly into the thread, and I start wiggling it back and forth as I'm pushing around until she makes contact with the shoulder. And I scribe the thread, and then I mark the thread back down the taper. Whether it be left-handed threads or right-handed threads, this is the actual location from the shoulder from which the pitch diameter is going to be taken. If this was a left-handed thread, the ink pen would have gone the other direction, but we'll cover that in just a second. It's always easier doing it inside the lathe because the lathe will be holding onto the part. My mark that I scribe down the crest of the threads is at about 1 o'clock. I take the fixed contact points. I set the fixed contact point at that point. The movable will follow the blue line down the taper, and I'm pivoting about the fixed point until I get to my lowest reading. And this one is a +1. Pitch diameter for a pin thread is +2 to -1. And that's all it is to measuring the pitch diameter. Now we'll do a left hand. Now we swapped over to an NC23 left hand. We still have to use the same template, 4 threads per inch, 2-inch taper foot, VO38, at no extra cost. The difference is the profile template will come from the back side, going counterclockwise up until it hits the shoulder. Then I back up, hold the profile template firmly into the threads, and then I start oscillating it up until the shoulder hits the front of the profile. I mark down the top. I locate my identification mark, but I only do a little short 1/2 inch long. If I was on the opposite side, I would run this pin around the back side down the taper. So what I'm going to do is I mark my location, because this is where the fixed ball is going to go. I do a little 1/2 inch mark, and then I reach over and I mark this one, because this one, if I come back around, comes up to the top. So this is going counterclockwise a half a pitch around, but because you don't want to climb inside the machine, it makes it easier. Then I still follow the same process. I place the fixed point onto the mark. We're going to zoom out a little bit. You see the indicator. I still have the fixed point on the mark. Now, I'm a half a pitch down the taper, but I'm actually on this groove going counterclockwise. Then I sweep to the lowest reading, and this one is reading a -1. So the only difference on left hand is you don't use your location mark and come down that groove, because being a left-handed thread, this is going up the taper. So I want to go down the taper, so I just do a little short mark where the template location is. Then I move over one thread, and then I scribe that line. So being as a machinist, placing the fixed point in, then I follow that blue line to the bottom. And that's all it is for a left-handed thread.